Good day, viewers. Welcome to my channel. Welcome to Master Builders Online Academy. You're welcome. So, guys, I want to sincerely appreciate you for subscribing to this channel, liking our videos, making positive comments, and then recommending this channel to those who you think that they need to get in touch with our mind-blowing content. Guys, I really appreciate every one of you for your love towards us on this channel. So, guys, again, we are here to learn and not to play. But one of the things that you really need to understand in our channel or in our content creation part, there are things that we really need to. So, one of the things that you need to understand is that there are guiding principles that we strictly adhere to in this channel. And one of these principles is that you should not skip any part of this video. This is because every segment and every part of this video are encrypted with principles that works. So when you skip any of these principles, gaining mastery over what you teach will become a problem. So this is one of the reasons why we advise that you do not skip any part of the video, because it will aid you to maximize every little principles that will unveil why we teach. So, guys, don't forget that when you understand principles, you become a principal. When you understand boundary conditions, you will not overstep your boundaries. We are here to raise masters and academic champions in the mind. Now, let's get into the business of the day. Like we have it, we have complex number on the board. So in this module, we shall be looking at complex numbers in details. And as such, complex number is actually very complex in itself. There are so many operations that we really need to carry out as we journey down demystifying this topic. So what we're going to do is that we are going to break this topic into different videos. So maybe when you are done watching this video, you can kindly check the description of the video so you have access to the next lesson, which will be a continuation of what we are about to do in this particular video. So if that is taken, let's dive into the actual work. Now, we have complex number on the board, and I hope that you say that prayer, right? So if you didn't actually say that prayer, make sure you pray that prayer so you can comprehend everything that I'm about to share in this video right now. So the first question you want to ask yourself, or you can be asked by an examiner, is what is a complex number, or what are complex numbers? So if you are asked, what is a complex number? What would you have to say? All right, let me not waste much of your time. A complex number is a number that contains real and imaginary components. A complex number is a number that contains real or imaginary components. Or you can simply put it this way: complex numbers are numbers that contain real and imaginary components. Are you there? And then generally, a complex number is denoted by a letter Z. So when you are dealing with complex number, this Z here is what we call complex number. But it is a combination of real components and then imaginary components. So the question is, how do these real components look like? And then how do these imaginary components look like? So generally, a complex number of anything, the general notation for complex number is given as this, as x plus iy, or z is equal to x plus jy. So it's either a complex number is given in this format or in this format. So this is the real component, all right? Then this is the imaginary component, all right? So this is the real component, this is the imaginary component. So the combination of real and imaginary component is what results to what we call complex number. So this is actually the complex number. So it shows that real component is a simple number. Imaginary component is a simple number. But the combination of two simple numbers gives birth to complex number. But the question now is, what is the actual difference between the real component and the imaginary component? Is it because this letter is X and then this letter is Y? Or couldn't this be written as A plus IY, or the same way as A plus GY? Sure. If you check some textbook, you will see it represented with X and Y. In other authors' book, you find A and B, rather, right? A and B. It can also be given as this. So the big question now is, what is the major difference between the real part and the imaginary part? Now, the real part is the part that doesn't carry this imaginary symbol. Remember, what makes this part imaginary is the presence of this symbol here, I or J. And this symbol is called the iota. Are you there? It's called iota. Iota. This is what this symbol is called. So this symbol is called iota. So when a number, an integer is accompanied by an iota, such number are considered as imaginary number or imaginary components. Are you there? So any number that comes alongside with this symbol, the iota, is considered as imaginary component. I hope you're understanding this. So the big question is, how come about this iota? This is where the complexity of complex number comes in. Are you with me? So now look at this clearly. This I is generally given as -1, which can also be J. So let me not be contradicting this. As far as this lesson is concerned, we're going to be using the I symbol. But one of the things is that it depends on your tutor, your instructor, your teacher, or your lecturer that determines whether you are using I or you are using J. So if he or she uses I to teach you or set your question, then you solve using I. If he or she uses this guy, then you also use it. So it's as simple as this. So you don't need to contradict or confuse yourself about what to use. Are you with me? Then if the textbook you are using, maybe the author, you use this symbol, then you flow alongside. And if the author you are using, and the other guy is this, then you flow alongside. But whether you make use of I or J, they all represent the same thing, iota, in complex number. I hope this is clear to some extent. Alright, so if this is clear, so this is a complex number, which is a combination of real component and then imaginary component. And then we now have this in this order, whether you use I or you use J. This is clear to some extent, right? Now, and I did mention that this I is given as the square root of -1. Of course, you know that with the help of your calculator, you cannot actually get the square root of a negative value. Take, for instance, you are asked to find the square root of -9. If you input this in your smart scientific calculator, you will see what we call syntax error or mark error. You can try this out. This is practical, all right? So make sure you get your calculator and try this out. So when you input this in your calculator, you will either see syntax error or mark error, which is what mark function error. Okay? So if this is clear, so how do I find this? Now, there is possibility of obtaining the square root of -9. So what you do in this case is to introduce the presence of iota using the theorem of salt. Are you there? But in order not to complicate things for now, let's move into the next segment of these contents. Now, we have been able to explain the concept of complex number. The next question is, in general notation of a complex number is more than what we have here. So that's what I want to take you through now. Now, remember that complex number in itself is actually defined or given with respect to Cartesian. Or that is given with respect to Cartesian, which is what? Your coordinate system. Every complex number that is given is with respect to a quadrant. And then we understand that in a coordinate system, we have 4 quadrants. Now, which is with respect that the general notation for every complex number is given as plus or minus the real part plus or minus the imaginary part. So for the first quadrant, let's call this Z1. Then second quadrant, we call this Z2. For third quadrant, we call this Z3. And then for fourth quadrant, we call this Z4. Alright? So now, in the first quadrant, both the real part and the imaginary part is positive. Are you there? Remember that when we talk about x and y, we are also using this as x-axis and then this as y-axis. So in the first quadrant, both x and y are positive. It shows that this is positive x plus iy. But in the second quadrant, now let me bring this back to you so you understand this clearly. So remember that this is positive x and then this is negative x. This is positive 1, and then this is negative 1. So here, both this is first quadrant, second quadrant, third quadrant, and then fourth quadrant, so that you can possibly see what I'm trying to explain here. So in the first quadrant, x is positive. Remember that this is where we are. S is positive here, and y is positive. But in the second quadrant, s is negative, y is positive. So we have negative x plus iy. Then in the third quadrant, x is negative, y is negative. We have negative x, negative y. Then finally, in the fourth quadrant, we have positive x, negative y. So we have x minus iy. So as you can see now, any complex number that you are given at all can either fall out to be any of these categories. Any of this category. Any of this category. So for example, a complex number can be given as z is equal to 3 plus 4i. Now, let me quickly also show you another thing that people do here. The same thing, this can be given as 3 plus i4. They all mean the same thing. Whether the iota symbol comes before the integer or the integer comes before the iota symbol, they all represent the same thing. So whether I'm given in this format where I comes later, or I'm given this where the integer 4 comes later, is still the same thing. I hope you're understanding this concept. They are all the same thing. So this is a typical example of complex number. Z is equal to minus 3 plus I2, or Z is equal to minus 3 minus I5, or Z is equal to 5 minus I6. Just like this. This is a typical example of a complex number. So in this case now, this agrees with the first quadrant. But this other guy agrees with the second quadrant. This guy agrees with the third quadrant. And then this guy agrees with the fourth quadrant. Any number or any integer can be given. Are you with me? Any integer can be given, like we have here, 6, 5, any number at all. But just understand that for every complex number that you will be given, it is either it falls out from the first quadrant, second quadrant, third quadrant, and then the fourth quadrant. Having been able to get the basic idea on what complex number is, the next thing we want to look at is the concept of conjugates of a complex number. So we have the conjugate of a complex number. Complex number have what we call conjugates. And this will be truly invoked when we start looking at the operations of complex number. But first is, what is the conjugate of a complex number? Or how do I get to know the conjugate of a complex number? Or how do I obtain the conjugate of a complex number? Understand that the conjugate of a complex number is actually obtained from a given complex number. And this is obtained by simply replacing the sign that connects the imaginary component to the real component of a complex number. I come again. The conjugate of a complex number is obtained by replacing or changing the sign that connects the imaginary part to the real part. Remember, if I am to pronounce this, for instance, this is 3 plus 4i or 3 plus I4. Is that correct? So in this case now, the sign that is connecting the imaginary part to the real part is the sign that comes immediately after the real part. So the sign that comes immediately after the real part is the sign that is changed to its opposite sign. It therefore shows that if I initially have positive there before, I will change it to negative. And then if I have negative there before, I will change it to positive. But understand that the sign that you change here is the sign that links up the imaginary part to the real part. So take for instance, if this is a complex number and then this is conjugate of complex number in summary. Okay, this is complex number. Then this is conjugate of a complex number. Are you there? So assuming I'm given 4 plus I5. So to get the conjugate, I will simply identify the sign that connects the imaginary component to the real component. So what sign? 4 plus I5. Is that correct? So this becomes 4 minus I5. Just change the sign that connects the imaginary part to the real part. Then again, if I have 3 minus I6. So in this case now, the sign that is connecting the imaginary side to the real part is negative. So in this case, the conjugate becomes plus I6. Now what happens if I now have minus 5 minus I7? This is the complex number. So how do I get the conjugate of this complex number, guys? All I need to do is to change the sign that connects the imaginary part to the real part. That means I am not concerned about the sign of the real part or the real component. My major focus is the sign that links up the imaginary part to the real part. So in this case, I have no business with this because it has nothing to do with the imaginary part. So you find out that the emphasis here is on the imaginary part. Remember, these are principles that will grant you access to master this topic. So otherwise, we have this as minus 5 plus I7. Then again, if I have this as plus I2, then this is minus 3 minus I2. So if you check now, the difference between this and this is that we just change the sign that connects the imaginary part to the real part. Now I want to quickly make something clear here. Listen carefully, okay? Listen, this is principle. Now whenever you have a complex number, understand clearly that the real part comes first before the imaginary part. Every complex number is given on the condition, listen to this, complex number is given as real component plus imaginary component. So the real part must come first. So what I mean now is that, take for instance, you are given minus I4 plus 3. And then you are asked to find the conjugate of this complex number. What will you change? Will you change this plus or will you change this? Remember, the sign that is changed is the sign that is directly in front of the imaginary part. I hope you got that. The sign that you changed is the one in front, the one that comes immediately after the real component. So it shows that when you are given something like this, this is not arranged in the sequential order. The order of arrangement proves that real parts come first. So that means if I want to find the conjugate of this, in my mind, I will first of all rearrange this as 3 minus I4. I hope you understand this. 3 minus I4. Remember, whether you put plus here or not, you are still very, very correct. Alright, so we don't need to put the plus here. So understand that in your mind, you may not do that here, but in your mind, interpret this as this. So that by the time you are changing this now becomes 3 plus I4. Remember, the sign will change. Is the one in front of the imaginary part. I hope you get this. Let me add to this. Then the same thing if I have minus I3 minus 6. Again, when you look at this, the imaginary part comes before the real part. But on the standard note, the real component is supposed to come first. So in my mind, I will rearrange this before I change the sign. So if I rearrange this will have given us minus 6. And then if I do this will give us minus I3. Are you there? So because of the fact that I am looking for the imaginary part, and then this was negative before, this will now become positive. Remember, to obtain the conjugate of a complex number, you actually change or replace the sign that links up the imaginary part to the real part. So if I have plus before there, I will change it to minus, and if I have minus there, I will change it to plus. I hope you have been able to gain values from understanding the concept of complex number, then understanding the concept of conjugate of a complex number. So without further ado, we are really going to dive into understanding the powers of the iotas. See you in that video.